seen example in the lectures like this and in the code. This temp is a concrete class. Get net monthly pay, as you may see, is overridden. The formula to compute it is just based on what was explained there. The only bit is that we have to move from integer values to float values because we want the real number of hourly worked total pay for this employee. So it was not some complicated expression. Some people had trouble with coming up with this kind of formula. It was just addition, subtraction, and arithmetic of low-level thing. Salary employee, it was an abstract class because as we don't implement get monthly pay, it stays abstract, but we do some declaration for methods which are used in derived classes. Get annual pay, for example, is defined there but is used in some derived classes from salary employee to compute. As you can see, for the administrator type object, we need to get the annual pay, divide by 12, and get annual pay is, as you can see, not declared in the admin class, but it comes from salary employee class. And then we have a formula very similar to what we have seen before. I have decided to have print for salary employee just to be able to pass data from the employee class via salary employee to its derived classes. And then for professor, I designed two data members, MTex and days leave, and in order to compute its net monthly pay, I have declared some variables with good name: compute monthly wage, day wage, deduction for leave, and then I compute gross wage, which is monthly wage minus deduction for leave, and then I take into consideration the text and return that value. For printing, again, base class for professor, prof class, plus information about the new data. So many things are, in a sense, quite repetitive. And hopefully you have got the idea. Yes?
Destructors? We had to write a destructor for the employee class?
For the employee class, what is this?
We had to write a destructor. Was the one? In the assignment, we had to write a destructor for basically the employee class.
To write a structure?
Destructor.
I see. Yes. If you put it, yeah, I forgot about it. You can add it, it doesn't do anything. Nothing. In some, yeah. It's virtual because of the, yeah, so you add it here and just empty brackets to practice with the syntax somehow. In the past, it was some warning that we have derived classes and they required call to their destructor. But apparently they fixed the problem. Any other questions? So that virtual destructor does nothing, just empty brackets, just to make some compilers happy.
Yeah, without the destructor, I was getting an error message. My
Yes.
one wasn't working.
But I think now, with some other compilers, they have fixed the problem. They recognize it's not memory allocated in these cases. In some other cases, it's important. So you lose nothing if you make the destructor virtual, and it's a good approach. Okay, right. So this was assignment 2 part 1, and now we are going. Okay, I have opened it already. Yep. We have started talking about standard template library, and we looked at iterators. And I mentioned that there are two issues about iterators. One is the hierarchy of iterators, which is not an object-oriented hierarchy. We have input iterators, output iterators, okay, forward iterators, bidirectional iterators, and random iterators. These are categories, and they are there to specify what operations are provided by classes of iterators as provided by various containers, what operations they should provide in order for various algorithms, which we'll talk next, to work on those iterators. Okay, so one is the notions of iterators category, and the other one is the classes of iterators as implemented by various containers. And on top of that, we will see that there are constant iterators, reverse iterators. We are briefly looking at the constant iterators. Once again, they are there to make some tasks work on constant containers. If you have a constant vector, a normal iterator does not work. If you want a vector, it's constant, you initialize it to some values, and then you just want to look at display data in that vector. Going with an input iterator through the vector does not work. The iterator has to be constant. In other words, to promise that it doesn't try to change data in the vector, which was constant. The compiler check. My data is constant, then I don't accept anything except constant iterators. And there are constant iterators and reverse constant iterators. So constant correctness is a big issue in C++. Reverse iterators, we are not talking because we are not practicing with them, so just I remove that topic. And at the end, a little bit about loops for ranges and iterators. So, we have covered input and output iterators. We have seen that iStream iterator is providing plus plus and dereferencing. This is the set of features for an input iterator. This dereferencing accepts values when we use it. Output iterator, on the other hand, is designed to go forward only and just to not change data, display it's a output thing. seen how to initialize these iterators with standard variables. Up on the hierarchy, we have the forward iterators, which can do input and output, but again, it moves only in one direction, as you can see, plus plus. And dereferencing, you can read data which is here, you can write data which is dereferenced. So it's providing a little bit more power. On top of that, we can compare, which was not compare and assign between forward iterators, and these operators were not available in the input and output iterator. Okay. Bidirectional are coming with all operations for forward plus the option, the power to move